So here we are in Chapter 5, Section 2, Energy. So go back to your middle school days and think about what you learned about energy here, and you learned about these two kinds of energy. Number one, the energy of objects in motion. The other one, stored energy. So objects in motion, you remember, is going to be kinetic energy, and stored energy is going to be potential energy. Now kinetic is pretty simple. It's kinetic energy. It's stuff moving. But potential can be stored in a number of different ways. The main way that we will discuss it is gravitational potential energy, and that is energy associated with your position in a gravitational field. This will be the one we use mostly in our class. But we'll also discuss elastic potential energy. That's going to be something that's tossed into this chapter. Later on in the year, we will talk about electrical potential energy, and we'll talk about atoms and them pushing at each other and whatnot. And then you could also throw in chemical potential energy. It's not a focus in our class, but chemical potential energy is extremely important in your life. That's why you need to eat food so you can get the energy out of your food. But gasoline and burning wood also have stored energy in those as well. So then we get into kinetic energy. And calculating kinetic energy it's a very straightforward equation. Kinetic energy equals 1/2 m, and the v is squared. So here we have an example out of the book where we have a bowling ball going. It's 7 kilograms going 3 meters per second. So you'd say that the kinetic energy equals 1/2 of 7 kilograms times 3 meters per second. Square that whole thing. Square the whole thing. So 3 squared is 9. 9 times 7 is 63. Half of that comes out to 31.5 joules. So joules is our unit for energy as well. Well, the sample problem in the book also says, well, how fast would a ping pong ball have to have the same amount of energy? So here's our ping pong ball mass here. So we'd set it up like this. 31.5 joules equals, let me stretch that out. 31.5 joules equals 1/2 times 0.00245 kilograms. That's a kicker right there. You got to make sure you have that. Times v squared. So then when you do your math here and you take half of the mass, you divide that over, you get something like 25,000 something. And then when you square root it, you're left with a velocity. I believe the velocity comes out to like 502 meters per second. And the reason that we talk about this, when you have a ping pong ball's energy compared to a bowling ball's energy, is you got the different factors yo-yoing here. We have a very slow bowling ball and a very fast ping pong ball. We have a very large bowling ball and a very small ping pong ball. Well, when you look at the formula for kinetic energy, the velocity is extremely important to the formula. If you double your velocity, you're actually quadrupling your energy because of the squared factor there. Whereas if you simply double the mass, you're only doubling your energy. So changing the velocity of an object greatly changes the energy of an object. And that's what we're getting at here. Now, associated with these notes is the homework located right there, 161 through 5. All right, good luck.